In this video, we want to continue with our first order separable equations, but we're going to answer two application problems. So let's start with this first one. We have a population model here. So a population of insects in a region will grow at a rate that is proportional to their current population. If there are initially 100 insects in the area, what is the population of the insects after 10 months? We're going to let x of t be the population of the insects after t months, and suppose it satisfies the differential equation dx dt is equal to 2x. All right, so suppose we have information that gives us that this is our differential equation. Then let's solve that. Since we've been talking about separable equations, how about we solve it using the method that we used in this section? So we have dx dt is equal to 2x, and we want to separate our variables here. So to do that, we rewrite this as dx over 2x is equal to 1 dt. We can integrate both sides here. So the integral of the left-hand side with respect to x is 1/2 ln of the absolute value of x is equal to, and then we integrate the right-hand side with respect to t, and so we get t plus c. Here we also have x of 0 is 100, so this tells us that 1/2 ln of 100 is equal to 0 plus c. Or in other words, c equals 1/2 ln of 100, which gives us the equation 1/2 ln of absolute value of x is equal to t plus 1/2 ln of 100. Or if we multiply by 2 on both sides here, this becomes ln of x is equal to 2t plus 100, ln of 100. Which is exactly what we've got written down here as our solution by the separable method. Now, notice that this equation is also linear. So we can solve this problem using our method that we learned in that section. So if we have a linear differential equation, we can rewrite this as dx dt minus 2x is equal to 0. This tells us p of t is equal to 2. The integral of p of t dt then is equal to 2t. So our integrating factor is e raised to the 2t. I made one small mistake here. This is a negative 2. So that is a negative 2t, and this is e to the negative 2t. And so if we have our integrating factor, mu of t is e to the negative 2t. We multiply that on both sides, and then we get the derivative of mu of t times x, which is e to the negative 2t times x, is equal to 0 times e to the negative 2t, which is still just 0. Now we want to integrate both sides. We get a constant on the right, and we just get this product on the left once we integrate both sides with respect to t. So we get e to the negative 2t times x is equal to some constant c. Here, x of 0 is 100. This tells us that e to the 0 times 100 is equal to c, or in other words, c is equal to 100. So our equation becomes e to the negative 2t times x is equal to 100, or x is equal to 100 e to the positive 2t. All right. And that is what we have written down here. Moreover, though, the question actually wanted us to find the population of insects after 10 months. So the equation we just had was x is equal to 100 e to the positive 2t. And we want to know, again, the population of insects after 10 months. So this is x is equal to 100 e to the 2 times 10. We just plug in 10 for t here, which is 100 e raised to the 20th power. And that is the number of insects after 10 months. If the population, of course, remains in check, i.e. this differential equation actually models the insect population. All right. Well, that is the end of our first problem. Let's move over to problem 2. And in this problem, we have that suppose a student carrying a flu virus returns to an isolated college of campus of 999 students. The rate at which the virus spreads is proportional not only to the number of infected students, but also to the number of students not infected. What is the number of infected students after 5 days? So we're going to let x of t be the number of infected students after t days. And suppose it satisfies this differential equation, dx dt is equal to 0.001x times 1,000 minus x. All right. So let's go ahead and get started here. And we want to rewrite this as a separable equation. It is not linear, right? If we see that we have an x times an x in there, so this is not linear. So rewrite this as a separable differential equation, and we get dx over 0.001x times 1,000 minus x, and all of this is equal to dt. Okay. From here, we have a couple of options. What if we multiply by 0.001 on both sides? So we instead turn this into dx all over x times 1,000 minus x is equal to 0.001 dt. So now that we have this, we need to figure out how to rewrite this so that we can actually integrate it. So this is our partial fraction decomposition. So we're going to have to work on that part. Let's go ahead and zoom in here so you have a little bit more white space to work with. So we had this fraction that we want to find the partial fraction decomposition of. So this is equal to a over x plus b over 1,000 minus x. Multiply both sides by x times 1,000 minus x, and we get 1 is equal to, the x's cancel on this term. So we get a times 1,000 minus x plus b times, and here the 1,000 minus x cancels, so we just get b times x. So if x is equal to 1,000, then we get 1 is equal to b times 1,000, Or in other words, b is 1 over 1,000. If x is equal to 0, then we get 1 is equal to a times 1,000, or a is 1 over 1,000. So what does this tell us? Well, this tells us up here that 1 over x times 1,000 minus x is, in fact, 1 over 1,000 all over x plus 1 over 1,000 all over 1,000 minus x. Okay. So this tells us that we had the integral of 1 over 1,000 all over x plus 1 over 1,000 all over 1,000 minus x dx is equal to 0.001 dt. All right, let's integrate both sides. We get 1 over 1,000, and now let's integrate 1 over x. We just factor out a 1 over 1,000 at first, and integrate 1 over x with respect to x, and we get ln of absolute value of x. And this becomes minus ln of 1,000 minus x. And this is 0.001 t plus some constant c. All right, if we plug in x of 0 is 1 here, we get 1 over 1,000 times, all right, x is equal to 1, so ln of 1 minus ln of 999 is equal to 0.001 times t, but t is 0 here, so this is just 0 plus c. Well, what does this tell us? Ln of 1 is 0, by the way. So this is just negative ln of 999 over 1,000 is our constant c. This tells us our equation is, in fact, we just erase this now. Doing that so we leave up the 1 over 1,000 times ln of x minus ln of 1,000 minus x. So this tells us our equation is 1 over 1,000 times ln of x minus ln of 1,000 minus x is equal to 0.001 t minus ln of 999 all over 1,000. And that is our solution to what the differential equation is, so i.e. what is our function x. So what is our function x? Then, if we want to know what is the number of infected students after 5 days, we go back into this equation. You plug in 5 for t, and then you solve this equation for x. And that will be the number of students infected after 5 days. All right, and that ends this video.